Hello everyone. So today we're going to solve this problem from the 15th Philippine Mathematical Olympiad national stage. This problem states, let R and S be positive real numbers that satisfy the equation the quantity R plus S minus RS times the quantity R plus S plus RS equals RS. Find the minimum values of R plus S minus RS and R plus S plus RS. So my approach in solving this is I'm gonna let A and B be R plus S minus RS and R plus S plus RS respectively. So let me write my solution. Let A be equal to R plus S minus RS and B be equal to R plus S plus RS. Then the equation will become AB equals RS. Now what I'm going to do is I'm going to add and subtract A and B. So I'm going to add them first. So adding A and B, we get A plus B equals 2 times the quantity R plus S, which implies that A plus B all over 2 is equal to R plus S. So I'm going to call this equation number 2, and I'm going to call the first one equation 1. So subtracting A from B, we get B minus A equals 2RS. And this implies that B minus A all over 2 equals RS. And I'm going to call this equation 3. Now, we can see here that from 1 and 3 that there's an RS term here. So, equating 1 and 3. So, we get AB equals B minus A over 2. Now, this becomes 2AB minus B equals negative A, and B equals A all over 1 minus 2A. Now, I'm going to call this equation 4. Now, in the original problem, it states that R and S must be positive real numbers. So we know that their product is also positive. So this right-hand side is positive. And we know that R plus S plus RS, this is also positive. Thus, R plus S minus RS must also be positive. So everything's positive, which means A and B are also positive. So we can infer from here that B here, the left-hand side, is positive. This is positive. And A is also positive. So everything here implies that 1 minus 2A must be positive as well, which implies that A must be less than 1/2. So we know that A must be greater than 0 but less than 1/2. Now recall that R and S must be positive real numbers. So since R and S are positive, by Vieta's formula, the roots of the equation, k squared minus quantity R plus S times k plus RS equals 0. So the roots of this must be positive. So this implies that the discriminant of this is R plus S squared minus 4RS. So since R and S are positive, real numbers, so this must be greater than or equal to 0. Now, this inequality, I'm gonna call this the fifth inequality. Well, technically the first inequality, but for consistency, I'm just gonna call this the number 5. Now, we express everything in terms of a. So then we express everything in terms of a. So recall that r plus s equals a plus b over 2 from number 2 here. So from here, so this is equal to a plus, well, we know the value of b. The value of b is a time, a all over 1 minus 2a from here. So using this, we substitute that in, all over 2. Now this will simplify to a times the quantity 1 minus a all over 1 minus 2a. And I'm going to use this as the sixth equality. Now similarly, rs is equal to ab, which is equal to a times quantity a all over 1 minus 2a. So this becomes a squared all over 1 minus 2a. And I'm going to call this the seventh equality. Now, I'm going to substitute 6 and 7 back to inequality 5. So since we expressed everything in terms of a, we'll have an inequality that is only in terms of a. So substituting 6 and 7 to 5, we get the quantity a 1 minus a all over 1 minus 2a squared minus 4 times the quantity a squared all over 1 minus 2a, which is greater than or equal to 0. Now, I'm going to multiply by 1 minus 2a squared, so I'm just going to multiply this by the quantity 1 minus 2a squared. Now, the left-hand side will become the quantity a times 1 minus a squared minus 4a squared times the quantity 1 minus 2a, and the right-hand side will still be 0. Now, I'm going to further simplify this, so a squared minus 2a plus a squared minus 4a squared plus 8a cubed. Now, all of this, when simplified, becomes a to the 4th plus 6a cubed minus 3a squared, which is greater than or equal to 0. And I'm going to take a factor of a squared out. So it becomes a squared times the quantity a squared plus 6a minus 3. Now, there are two factors here. So a squared here, we know for a fact that a squared is always going to be non-negative because, well, we already know that a is positive. Well, actually, a squared is always positive. So we know for a fact that the first factor, a squared, is always positive. So we know for sure that a squared plus 6a minus 3 must be greater than or equal to 0. But we're trying to find the minimum here, so we just equate this to 0 and then solve for a. So solving for a, so we know that a squared plus 6a minus 3 equals 0. So by the quadratic equation or quadratic formula, we get a is equal to negative 6 plus or minus the square root of 36 plus 12 all over 2. Now, this will turn out to be negative 6 plus or minus 4 times the square root of 3 all over 2. And this will become negative 3 plus or minus 2 times the square root of 3. But since a is between 0 and 1/2 from what we got earlier, so a is equal to negative 3 plus 2 square root of 3. Now we have a value for a. Now we're sure that this is the minimum because when we plug it back in to a squared plus 6a minus 3, it will yield 0, which is the lowest value that it can get. Now we just plug it back to solve for b. Now we know that b is equal to a times, or a all over 1 minus 2a. So this is from the fourth equation, which is equal to negative 3 plus 2 square root of 3 all over 1 minus 2 times the quantity negative 3 plus 2 square root of 3. Now this becomes negative 3 plus 2 square root of 3 all over 7 minus 4 square root of 3. Now, rationalizing the denominator and just simplifying this will yield 3 plus 2 square root of 3. Now we have values of a and b. So therefore, the minimum value of a, which is equal to r plus s minus rs, is equal to negative 3 plus 2 square root of 3, and b, which is equal to r plus s plus rs, is equal to 3 plus 2 square root of 3. So these are the two values, or the two minimum values. So we're done.